In this video, I'm going to take you through some National 5 change of subject questions, and then I'm going to show you how we can take this a little bit beyond National 5. I've got 5 formulae on the screen here, and what I'm going to do in each case is I'm going to make the highlighted letter the subject. So essentially what that means is I'm going to move all the other terms around about. I'm going to rearrange the formula to get them into the form n equals, b equals, w equals, and so on. And essentially what we do is we do exactly the same steps as if we were solving an equation. Because we've got an equal symbol here, we can essentially do whatever we want to one side, so long as we do the same to the other. Here I've got n over 9 plus k. I'm trying to get the n on its own, and n is trapped inside this fraction, so it means I'm going to need to get rid of this plus k to begin with. So we think in terms of either inverses, i.e. the opposite function, or we can think in terms of zero pairs in this case. To get rid of this plus k, I'm going to introduce a negative k. If I've introduced a negative k to the left-hand side, I need to introduce one to the right-hand side. This means on the left-hand side, I'll have my n over 9, the positive k and the negative k form a zero pair there, and that'll be eliminated. On the right-hand side, I've got m minus k. I can't write this as anything else because m and k are unlike terms. They're totally different letters, totally different variables. So I've just got to leave this as m minus k. Now, I've got the n trapped in the top of this fraction, so I need to get rid of this over 9. This means divided by 9, so to cancel that out, to get rid of that, I'm going to do the inverse. I'm going to multiply each side of my equation by 9. That is going to leave me with an n on its own. And that is going to equal 9 lots of m minus k. There's no need for me to expand the brackets. This is perfectly fine written like that. I could, I suppose, when I'm writing this out, I could just go, I'm going to multiply everything here by 9, and I could go 9 lots of m minus 9 lots of k, and that would also be fine. But generally speaking, brackets are what you want to be using. It's going to save you making any unnecessary errors. Second one, I want to get this b on its own. So the b is part of this term here, so I'm going to need to get rid of this minus 3 to begin with. Thinking in terms of a zero pair, or in terms of inverses, to get rid of that negative 3, to get rid of minusing 3, I'm going to add positive 3. That's going to leave me with this ab squared, and on the left-hand side, the right-hand side, sorry, I'm going to have e plus 3. Again, this can't be written in any other format because e and 3 are unlike, so we're just going to have to leave it as e plus 3. Now, we need to be careful here. What this means is this means we've got a times b squared. So I'm wanting to get this b term on its own. I want to get this b squared on its own. So I'm going to need to get rid of this a. I'm going to need to undo multiplying by a. So this means I'm going to have to multiply both sides of my equation by a. This means on the left, I'll be left with a b squared. On the right, well, I'm just going to leave this as a fraction. I'm going to have e plus 3 all divided by a. Now, I've got the b on its own. However, it's not just b here, it's b squared. So I'm going to need to unsquare that. More mathematical way of saying that is I'm going to need to take the square root. So if I take the square root of the left-hand side, I'm going to be left with b. I need to take the square root of all of the right hand side. So this means I need to have a nice tall square root symbol, and I'm just going to put a roof over the top of it to show all of this is being square rooted here. Now, the ones at the bottom, we introduce some more fractions and still working with square roots, but the process is going to be exactly the same. So to make w the subject in this next one, I want to get this root w on its own, so I'm going to get rid of this 2h. Don't let the fact that this is 2h fool you. We have got root w plus 2h. So to get this w term on its own, we are going to need to get rid of this adding 2h. So we are going to start by subtracting 2 h's from each side. That'll leave me with square root of w. I've put a little roof on the symbol. It doesn't need to be there, but I prefer it. The plus 2h minus 2h is a zero pair, so we're going to have no h's on the left hand side, and I'll have 7 minus 2h on the right. I've got a w on its own, but it's trapped under this square root symbol, so I'm going to do the inverse. I'm going to square both sides. Now, be careful with how we're setting this out. If I square the square root, it's going to leave me with a w. And that is going to be equal to all of this squared. So I am going to write that just using brackets. Be very careful. There might be the temptation to write something along the lines of 7 squared minus 2h squared. But remember, if we were to multiply this bracket out here, it would give us a trinomial. It would give us something with a number term, an h term, and an h squared term. So it's safer just to leave it in this form. Next one has some brackets in it, as well as a fraction. I'm going to make h the subject here. So h is trapped within these brackets and is trapped within the fraction. So we can't really get to the brackets here until we deal with the fact that this is a fraction. So I'm going to get rid of this divided by d by multiplying each side by d. The multiplication is going to cancel out that division. 7d. It's important to realise here that the SQA won't accept 7 times d there, because everything needs to be written in its simplest form. So 7d is the simplest way to write that. To get the h on its own, we could expand the brackets here, but that tends to get messy. So what we're going to do is we are going to say, well, this is 3 times the bracket. So if we divide each side by 3, we are going to be left with h plus w equals 7d minus 3. 7d over 3. Almost got the h on its own. We've got h plus w. So if we subtract a w from each side, that is going to give us h equals 7d minus 3 minus 7d over 3 minus a w. And we've successfully got that h on its own. We've made h the subject. Last one, we've got h trapped on top of a fraction, trapped underneath the square root symbol. So first thing we need to deal with, we essentially need to deal with the thing that's furthest from the h. So we've got the top of the fraction, the bottom of the fraction, the square root over them. So to start, we need to square both sides. Excuse my handwriting. So if we square the left-hand side, that is going to cancel out that square root symbol. If we square the right-hand side, we're going to have t squared. Now it's important to note if this t here was a number, say that was 4, rather than writing 4 squared, we'd be expected to write 16 there. Again, it's all about keeping things in their simplest form. We've got h on top of the fraction, so we need to deal with that over 5. So to get rid of that division, we're going to use multiplication. So that's going to give us h minus w equals 5 lots of t squared. H is almost on its own. We need to get rid of the minus w by adding w. So we add w to each side. It's going to leave us with h equals 5t squared plus a w. And those are all questions that are at National 5 level. So here would be a natural point to just move on to getting on with some questions if you're just wanting to focus on the bare minimum, okay, just working on the National 5. But here I've got a couple of questions that take us a bit beyond National 5. Here we want to make t the subject of this formula, and we've got a problem, and I've got a t on the left and I've got a t on the right. The subject appears twice. Our tactic in this occasion is to try and get all the letter t's over to one side. So we're sort of dealing with this in the same way we would deal with solving an equation. If we had a variable on each side, be it a letter x or whatever, we would need to group all those x's together. This is one of these rare occasions where I am going to have to multiply out my brackets to begin with. So I've multiplied that bracket by 5, and I've not done anything to the right hand side. I've got 5t on the left hand side, I've got 2t on the right, so I'm going to minus 2t from each side to leave me with 3t minus 5g equals, and on the right hand side I'll just have a 7. This now becomes just like the previous examples. I want to get the 3t on its own, so I'm going to add 5g to each side. It doesn't matter that this is 5 lots of g here, we're just treating this as one object, as one term. We need to get rid of this to get this bit on its own. So that'll leave me with 3t is 7 plus 5g. Again, these can't be grouped together here because they're unlike. I have got 7 and then I have got 5g's. All that remains to be done here is to divide the left hand side by 3 and the right hand side by 3 to get me a single t equals 7 plus 5g all over 3. We've ended up with a single letter t on the left hand side and all our other terms on the right. Now that's a nice straightforward. Here I want to make m the subject, and again the letter m appears twice. Now you might think this is going to be exactly the same as the one before, but when I start moving things about it should hopefully become clear that it's not. So I've got this negative 3m on the right hand side. So I'm going to add 3m to each side of my equation. On the right hand side, so I'll just concentrate on that for a second, it's going to leave me with the letter g, and because I've got negative 3m, positive 3m, this is a zero pair, we're not going to have any m's here at all. The problem creeps in when I try and group these two together. I've got am plus 3m. I've got a letter coefficient and a number coefficient, so I cannot group those together. I've got am plus 3m plus 5. Now, the issue is we're wanting to get a single letter m on its own, and by moving this across, by adding 3m to each side, I've still got 2 letter m's, so I'm going to need to deal with that. First things first though, I'm going to get rid of this plus 5 by minusing 5. So now at least the only terms that are on the right hand side are ones involving m. Now, this is the clever bit. Both of these terms have got a letter m in them. Both of these terms have got an m in common. So I can factorise. I can take out a common factor of m. I'm going to have m multiplied by a for the first term and m multiplied by 3 for the second term. So I've not done any rearranging. All I've done is I have factorised the left-hand side. But where I've had 2 letter m's, I've now only got 1. So this is quite a neat trick, quite a useful trick. Not one that you would need at National 5 for a rearranging, but still a nifty little thing. So here I've got m multiplied by a plus 3. So think about it. If I had 5m and I wanted to get m on its own, I would divide by 5, because the inverse of multiplying by 5 is dividing by 5. So here I've got m and it's being multiplied by a plus 3. So the inverse of multiplying by a plus 3 is to divide by that bracket. So I am going to divide the left-hand side by a plus 3, and I'm going to divide the right-hand side by a plus 3. The multiplication and the division on the left-hand side are going to cancel out. It's going to leave me with an m. Common factor divides away. On the right-hand side, I've got g minus 5 divided by a plus 3. Now I can write this with or without brackets. It's entirely up to you. Next one, this is the worst case scenario. I'm going to write it in the middle of the screen here rather than off to the side. So again, we want to make a letter the subject, and it appears twice in our formula. However, to make things a little bit more miserable, the letter appears twice within the same fraction. So our technique here is to get rid of the fraction. It doesn't matter we've got an expression on the top and an expression on the bottom. If I put it in some brackets in there, it could hopefully make it clearer that we can just treat this as a fraction like that, m equals a over b. And I can get rid of the fraction by just multiplying both sides by the denominator. And that is going to get rid of this horrible division, right? So this is what I'm going to do here. I'm going to divide each side by t minus 3. So I'm going to multiply the left-hand side and the right-hand side by t minus 3. On the left-hand side, I'm going to get m lots of t minus 3, and that is going to be equal to t plus 1 on its own, because the division and the multiplication are going to cancel each other out. And this is what an inverse is. Dividing by t minus 3 and multiplying by t minus 3 are going to have no effect on the t plus 1. They're going to leave it as it is. Right, now we've got rid of the fraction, but now the t's are on two sides. So just like the previous examples, I'm going to multiply these brackets out. So I've got mt minus 3m. On the right hand side, that's just t plus 1. And I'm going to bring all the t terms over to the left hand side, and if it doesn't have a t term, I'm going to bring it over to the right. So I'm going to start by subtracting a t from each side. So that's going to give me mt minus a single t Again, we can't group these as a single term because we've got a letter coefficient and a number coefficient. We've got m and we've got -1 for our coefficients. I've got the -3m still on the left, and I'm left with that +1 on the right. I'm going to get rid of this -3m by adding 3m to each side. So that's going to leave me with the mt minus t on the left, and now I'm going to have 1 plus 3m on the right. Now, two instances of the letter t, both of these terms have the letter t in common, so I just take it out as a common factor. And this is just t multiplied by this expression. So to get rid of the multiplication, I'm going to divide each side by m minus 1. Divide each side by m minus 1. So that will leave me with multiplication and division cancelling out. It's going to leave me with a single t equals 1 plus 3m all over m minus 1. And I've successfully got a single t on its own. I've made t the subject there. So this would give you the opportunity to try some rearranging, changing subject questions that are above the National 5 level. But remember, National 5, as it currently stands, you're only going to have the variable that you're trying to make the subject appearing once. So things like this take us beyond the scope of the course.